when reviewing for the Chapter 3 quiz, we are going to use one problem and kind of go over everything that we talked about in Chapter 3. So in our problem, we are looking at the temperature in degrees Celsius, the average March temperature in degrees Celsius over 24 years, and then the date in April the first Japanese cherry blossoms appeared. So the days would be like the date in April. So the 14th, the 8th, the 11th, the 19th, so on for the 24 years. And then below that, we have the average March temperature in degrees Celsius in our table. So 4, 5.4, 3.2. And I know for degrees Celsius, this seems like a very small number. But if you converted it to degrees Fahrenheit, something that, as Americans we're more comfortable with, it would make more sense. So the first thing we want to do is determine our explanatory and response variables. So there are two ways you can kind of go about doing this. You can look at your table, okay? But you can also take a look at the wording of the problem itself. So if you look at the sentence that starts with like the third sentence, it says, experience has taught us that if the spring has been a warm one, the trees will bloom early, but if the spring has been cool, then the blossoms will appear later. So that kind of leads me to believe that the temperature is the one that is affecting the date that the blossoms appear. So my explanatory is going to be the temperature in degrees Celsius, and my response is going to be the day. Right? Now, typically, if we're looking at the table, 9 times out of 10, we're going to see the explanatory variable on the top and the response on the bottom. But that's not how it's always going to happen. So reading the context of the word problem is definitely helpful. So I'm going to highlight the sentence that kind of helped me determine my explanatory and my response. So if you think about it, like the temperature should affect when the tree blooms, not, the tree blooming isn't going to impact the temperature. So thinking about it also leads me to believe the explanatory is the temperature. Okay. The next thing I did is I created a scatter plot using sheets because it was a whole lot easier to organize the data and it looks a lot neater. So along the bottom, I have my temperature in degrees Celsius. And then along the side, we have the day that it first appeared. So I want to describe it. So I want to look at my scatter plot and see what I can kind of already interpret. So if I look, I can see that this is a negative relationship. Okay, so as temperature increases, the earlier the day the blossom will appear. Which kind of makes sense. Like the warmer the temperature, it kind of makes sense that the cherry tree would bloom sooner because it's warmer. And if it's colder, it's going to take longer. Like if we look at our one day over the last 24 years where the average temperature in March was 1.5 degrees Celsius, it took until the 28th of April for that cherry tree to start blossoming. So this kind of makes sense that my relationship would be negative. Okay, so now we want to use our data to calculate our least squares regression. So I already put my data into list 1 and list 2 on my graphing calculator. So remember, list 1 is going to be our explanatory, which is the temp, and list 2 is going to be our day, And then once we have all of the values in, we're going to go over to calc and then 4 for Lin Reg. And then we're going to calculate. So we get A equals negative 2.57 and B equals 23.44. So when I write my equation, y hat equals A, negative 2.57x hat plus B, 23.44. So next we are going to interpret the slope in the context of the problem. So to just rewrite my slope, we had A equals negative 2.57. And when we think about what slope is, it's the change in the y over the change in the x. So what I can say is the earlier the cherry tree blossoms, the warmer the temperature. And we can back this up by looking at our graph. Next, we want to interpret the x and y-intercepts in the context of the problem. So I'm going to start with the y-intercept since that's given to us from our equation. So our y-intercept is 23.44. So we think about how we get a y-intercept. We plug in 0 for x, and x represents our temperature. So the day the cherry tree will bloom, when the temp is 0 degrees Celsius. So if it's 0 degrees Celsius, the cherry tree won't bloom until roughly the 23rd day of April. Okay. Next, we want to find our x-intercept, which is the x value when y is 0. So thinking in terms of the context of this problem, we're basically figuring out what will the temperature be in order for the cherry blossom to pretty much bloom before April, because then our day of the month would be 0, which would technically tell you that it doesn't happen in April. So in order to find the x-intercept, we basically have to solve. And when we solve our equation for x for when y is 0, we get 9.12. So saying that it's the temp, the tree blooms before April. So pretty much if the temperature is 9.12 degrees Celsius or higher for the average March temperature, the cherry tree should bloom before April even starts. Okay. Now we want to calculate our correlation coefficient and then talk about what it describes. So we go back into our Lin Reg statistics. We don't have to change our graph. And we look at R. We're going to get R equals negative 0.85. So now I want to discuss, what this describes. So what this tells me is that there is a strong negative correlation between the temperature and the day the cherry tree blooms in April. So negative 0.85, pretty strong negative correlation. All right, which, looking at the graph, we already knew it was going to be negative from question 2. And then when we looked at the slope, because slope is calculated using correlation coefficient and standard deviations are always positive, kind of led us to believe that R would be negative. So it's not surprising that R is negative, and then most of the values were pretty close together, which led me to believe it was going to be a strong relationship as well. So that leads us directly into number 7, which asks, if R is high, can we conclude that a change in temperature causes the blooms to appear at different times? Then we want to explain. I'm going to put this in all caps. The answer is no. And the reasoning is correlation does not mean causation. All right, there are going to be other factors that cause the cherry blossoms, blooms to appear at different times. Just there's a strong correlation between the temperature and the day. Does not mean it causes it. This is a huge thing in statistics. I would definitely star, highlight, box, something for number 7. Correlation does not mean causation. It just means that there's a relationship. Does not mean that it causes it. Sorry, the bell rang. I'm going to record a second video for the rest of the problems for the quiz review. So for day 1, you should get through the first 7 problems, and then for the second day of the quiz review, finish it. I will have a separate key created for that. If you have any questions over anything I did from the first 7 problems, please reach out before the quiz.